Hi, welcome to my talk, GitOps, Kubernetes, and Secret Management. Don't bake in a tent. I'm Cara Delamarque. I work at CloudBees, mostly with the Jenkins X open source community. Jenkins X is a CI/CD platform on Kubernetes with GitOps built in. I'm committed to facilitating GitOps best practices. In this talk, we'll be discussing some of the difficulties of secret management with GitOps and Kubernetes, some secret management strategies, what trade-offs they present, as well as tools and approaches that can help. Secret management with GitOps and Kubernetes is the subject of this talk, not an in-depth dive into all aspects of GitOps or Kubernetes. Firstly, we'll go briefly over our terms and set the context in which we're considering the problem of secret management. And secret management is an issue across all of software development, but in this talk, we're looking at it within the context of GitOps and Kubernetes. First, why Git? Doesn't have to be Git, but Git is the most widely used version control system in the software industry today. And also note, Git just celebrated 15 years of being released as an open source project. So happy birthday, Git, and hence the cake. GitOps uses Git as the single source of truth for declarative infrastructure and enables developers to manage infrastructure with the same Git-based workflows that they use to manage a code base. This means all infrastructure configuration and application code are stored in Git repositories. Infrastructure as code isn't unique to GitOps, but it is foundational for GitOps. With GitOps, the entire state of your system is described using declarative specification for each environment, and these are stored in Git. So a key part of GitOps is this idea of environments as code, describing your deployments declaratively using files such as Kubernetes manifests stored in a Git repository. And this, having infrastructure config and deployments declaratively described in files in Git raises issues of secret management. And secret management with GitOps and Kubernetes is this talk. But if you would like to learn more about GitOps, the term was coined by Weaveworks, and recommend going and looking at their writing on the subject. So at our high level, for this talk, the desired state of your system is declared in Git, and this is the single source of truth for your system. The other part of GitOps, which is important to keep in mind, is that you have to be able to observe the actual state of your cluster, the state of your system, and reconcile that actual state to your desired state as declared in Git. So Kubernetes helps a lot with this. It handles active reconciliation within your cluster. So Kubernetes was open source from Google and is now the most popular container orchestration platform. You can do GitOps without Kubernetes. However, GitOps and Kubernetes are really a natural fit. When you have a Kubernetes deployment, it has the following properties which are really useful for reconciliation, for automating that reconciliation within the cluster. First, automation. It automates the process of applying changes correctly and in a timely manner. And then we have convergence. Kubernetes will keep trying to update until the update is successful. And idempotence. Multiple applications of convergence have the same outcome. Convergent actions can be applied multiple times without changing the result beyond the initial desired outcome. So when you're doing GitOps with Kubernetes, it's helpful to have a GitOps Kubernetes operator, which automatically ensures that the state of your cluster matches the state of your config in Git. So the operator kind of handles that communication between, or automates that communication between the Kubernetes cluster and the desired state of your system as represented in Git. The operator pulls the Git repo for changes or divergence between the desired and the actual state and triggers deployments when necessary. It makes sure that your new container images and config changes are propagated to the cluster. So Flux is a GitOps Kubernetes operator that has been open sourced by Weaveworks. Jenkins X also has a GitOps Kubernetes operator for doing continuous delivery. For the purpose of this talk, then, we're going to assume Kubernetes usage and that you're aiming for GitOps best practices. And this is great because the combination of GitOps methodology with Kubernetes declarative configuration and active reconciliation model combine to provide a number of operational benefits that all aim to provide a more predictable and reliable system. So having all of your configuration files version controlled by Git has many advantages. But securely managing secrets in such a system has proven difficult. So first, what's a secret? A secret is anything you want to tightly control access to. Kubernetes provides a mechanism allowing users to store bits of sensitive information into a protected resource object called a secret. So Kubernetes provides a built-in object for managing secrets called a secret. Common examples of data you would want to store in a secret include username and password credentials, SSH keys, API keys, TLS certificates. Okay. This is an example of a simple Kubernetes secret. It is a simple data structure composed of 3 main pieces of information: the name of the secret, the type of the secret, which is optional, and a map of field name to sensitive data encoded in base 64. When you first see a Kubernetes secret, you may be tempted to think that its values are protected by encryption. They are not. Base 64 encoding allows binary data to be represented in ASCII string format. It does not provide encryption. The reason Kubernetes does base 64 encoding is so that secrets can store binary data. And this is important for things like storing certificates of secrets. You do not want to store Kubernetes secrets in Git. The base 64 encoding is like plain text. So as we can see here, the secret data, easily unencoded, is reading username, let's all join, and password, I need cake. So you do not want your secrets laid out in Git like an open buffet. GitOps practitioners may be very happy to store configuration files in Git, but they are unwilling to store their sensitive data in Git due to security concerns. Now, there are additional reasons it is a security concern to store secrets in Git. Git was designed as a collaborative tool, making it easy for many people to view and review each other's code. It was designed to enable access to other people's code. And for these reasons, it is very dangerous to use Git to hold secrets. A couple examples are there's no granular file level access controls. So Git does not provide a read mechanism in a subpath or a subfile in a Git repository. In other words, it is not possible to restrict access to some files in a Git repo and not others. So when you're dealing with secrets, you ideally should be granting read access to secrets on a need-to-know basis. And for example, if you have a temporary worker, you would want to give that new user the least amount of access to the sensitive data. But with Git repos, it's all or nothing. So if they have access to your Git repo, they have access to everything in that Git repo. Also, distributed Git repos. So with GitOps team, your members are going to locally clone the Git repo to their laptops and workstations. And this would mean the proliferation of secrets to many different systems and opening up the surface of attack. So if any of those laptops were stolen or workstations compromised, then your secrets would be open to attack. Okay. So our one rule for GitOps, Kubernetes, and secret management is don't store Kubernetes secrets in Git. But we are trying to do GitOps and have the entire state of our system in Git. Luckily, there are a number of potential solutions, but unfortunately, all of these solutions come with trade-offs. Plus, the state of the art keeps changing, and often the differing recommended strategies sometimes contradict each other, and this can leave someone who's trying their best and trying to use best practices to feel like it's a bit confusing, and it often gives contradictory advice that keeps changing. Okay, and this is similar to in the following spoof, which we're going to watch. It's a spoof of the British Prime Minister giving the latest physical distancing guidelines to the UK. And these, like many places in the world, these physical distancing guidelines in the UK keep changing. And this is actually really confusing and frustrating for people. So this is a little spoof done by a comedian and writer, Matt Lucas, when he joined a TV program called The Great British Bake Off, where they in fact spend the entire program baking an attempt.
First, an important message. I talked about this, but I do know the printer is upside down again, and I don't know. Well, how? Well, maybe. Oh, yes. Well, that works. Actually, I can read that fine. Right. Let's. Yeah. Good evening. Let's get straight to it. We are now approaching phase 46, which means that from Tuesday morning or Wednesday evening, depending on your height, we are saying, with regards to baking, if you must bake in a tent, but please don't bake in a tent.
Okay, after that spoof, we'll now introduce the different strategies for managing secrets with GitOps and Kubernetes. And we'll aim to provide some clarity on the different strategies and their trade-offs. And we will hopefully provide more clarity than that spoof. Remember, right now we have one rule for GitOps and Kubernetes and doing secret management, okay, which is do not store Kubernetes secrets in Git. To help us with the conundrum of what we do with our secrets, there are a number of different strategies for secret management, and they have trade-offs around flexibility, security, and manageability. At the end of going through these different strategies, we'll look at the secret management strategy that Jenkins X has adopted. So the first strategy of secret management is to break the rule. Okay. In other words, you simply commit your secrets to Git like any other Kubernetes resource and accept the security consequences. Now you might be tempted to think, well, what's so wrong with that? I have a private Git repo, only trusted members of my team have access. But okay, in addition to the reasons we've gone over before, you may very well want to have third-party software have access to your repo. So for example, CI/CD systems or security scanners or static analysis tools. By providing access to your Git repository with secrets in it, these third-party systems now have access to your secrets. And in practice, this is not a strategy for managing secrets. Okay. But remember, we are dealing with guidelines similar to don't bake in a tent, unless you're going to bake in a tent, in which case, bake in a tent. So, don't store secrets in Git unless you're going to store secrets in Git, in which case use encrypted secrets. The idea is to encrypt your secret into a sealed secret, which is safe to store even in public Git repos as it's encrypted. The challenge with using encrypted secrets in Git is that there's still at least one last secret involved, and that's your encryption key. That encryption key needs to be very well protected, as anyone with access to that key then has the ability to decrypt and gain access to your sensitive information in the manifest. However, there are some solutions around this concern, and if you're interested in finding out more about encrypted secrets, Benami Labs sealed secrets are one popular tool. So to avoid storing secrets in Git, if you decide you do not want to do that, one strategy that may come to mind is to bake the sensitive data directly into the container image. In this approach, the secret data is directly copied into the container image as part of the Docker build process. The advantage of this approach is that it removes Git as a concern entirely, and it even removes Kubernetes, because with the sensitive data baked into your image, you could run that theoretically anywhere, not just in Kubernetes. However, baking the data into the image has some very big drawbacks, which might rule it out as a viable option for you. First, the container image then becomes sensitive. So if anyone has access to that image, say from a Docker pull, they will then have access to your secret. Another problem is that since the secret is baked into the image, it makes it very difficult to update that secret, and it makes it cumbersome to do so. So whenever certificates need to be rotated or something like that, you would then need to basically build another image. Okay, it's kind of like if you baked a chocolate cake one night, and then the next morning you want to have cake with your coffee, but you want a vanilla cake. Well, you can't just take the chocolate out of the cake, it's baked in. You have to go bake a vanilla cake. Okay. And similar third problem is that the secrets that are baked into the container tend to be less flexible. So if you have, for example, 3 environments you want to deploy into, and they all need different access to different databases and therefore have different sensitive data, then it becomes really hard to do that with the same image. It's not very flexible at all. Okay. So now we have kind of 2 rules for don't bake in a cake in a tent are rules for GitOps, Kubernetes, and secret management. 1, don't store raw Kubernetes secrets in Git. And 2, don't bake sensitive data directly into your container images. Okay. And really the second rule here is more of a guideline because you can do it, but there are a lot of trade-offs around security, flexibility, and convenience. Okay. So really, we just have one rule, which is don't store raw Kubernetes secrets in Git. And as you've seen, using secrets is optional in Kubernetes, but it is much more convenient, flexible, and secure than the other techniques, such as baking the sensitive data directly into your image. Since secret object is convenient to use as well, it provides a declarative API that makes it easy for application pods to access the data without any special code. So there's a lot of convenience with using Kubernetes secrets. And so we want to use Kubernetes secrets, but how to do so securely? Now, one approach is to, say, outsource all your baking needs to those with access to a professional kitchen, rather than trying to bake in a tent. And in the world of secret management, this means using an external secret management system. And these professional bakers can do a lot for you. They can securely store and manage your secrets. You have identity-based access to sensitive information, data encryption in flight and at rest. And there are a variety of external secret management systems that exist. One of the most popular is HashiCorp, Vault, and in addition, the individual cloud providers also offer secret management services. So we have like Google Secret Manager, AWS Secret Manager, Azure's Key Vault, Alibaba's Cloud's Secret Manager, and they might differ a bit in features, but the general principles are the same. So in this strategy, rather than using native Kubernetes features to store and load secrets into a container, the application containers themselves retrieve the secret values dynamically at runtime at the point of use. Okay. But however, when using an external secret store, it is the responsibility of the application to retrieve the secrets from the store securely. And often teams develop custom solutions for accessing secret data. The result is that there are overlapping efforts for developing these solutions. And because security is vital in this context, each individual effort can require substantial engineering time. And so all that blank gray space in the diagram, that's your engineering time. So luckily there's Kubernetes External Secrets, which has been open sourced by GoDaddy. Kubernetes External Secrets enables the secure retrieval of secrets stored in external secret management systems and the ability to securely add secrets to your Kubernetes cluster. The project extends the Kubernetes API by adding an external secrets object using a custom resource definition and a controller to implement the behavior of the object itself. An external secret declares how to fetch the secret data, while the controller is responsible for fetching secret data from external providers and converts all external secrets to secrets. The conversion is completely transparent to pods that can access the secrets normally. Kubernetes External Secrets supports the external secret management systems of all the major cloud providers, as well as HashiCorp Vault. Okay, so if we look at this a little bit more closely of what's happening, first, the external secrets are added to your cluster. And you can kubectl that apply, or Jenkins X can do that for you. The controller fetches external secrets using the Kubernetes API. Second, the controller uses external secrets to fetch secret data from the external secret management system. Then the controller upsorts those secrets, and the pods can then access the secrets normally. So I kind of gave that away, but Jenkins X is recommending usage of Kubernetes External Secrets. Number one, we obviously don't want you to commit raw Kubernetes secret YAML into Git. And you can use sealed secrets, but we do highly recommend using Kubernetes External Secrets, which means you can check in external secret resources into Git, which are a reference to the actual secret values from some provider, okay? And Jenkins X supports the major external secret management providers, including HashiCorp Vault, Amazon Secret Manager, Google's Secret Manager, Alibaba Cloud Secret Manager, Azure Key Vault. Okay, so the Jenkins X team are big fans of Kubernetes External Secrets, and to the point we developed JX Secret, which is a small command line tool for working with Kubernetes External Secrets that integrates really nicely with the Jenkins X workflow for continuous delivery on Kubernetes. So Jenkins X has chosen a strategic management approach that adds an abstraction layer above secret management solutions from external providers, so users can choose where they're going to store the source of their secrets, and this will be preferably outside of their Kubernetes cluster. And this is very good practice for disaster recovery scenarios. Okay, so here are some more links to discover more about Jenkins X3 Alpha, how it differs from Jenkins X2, some of the architectural changes that have been made and why. Go check it out, it's a great project. And also here are some links for finding out how to become more involved with the Jenkins X community. You can join us for our bi-weekly office hours, our Slack channels, Discourse, we have SIGs, and also we are participating in Hacktoberfest. Okay, so very quick wrap up. TLDR, GitOps enables developers to treat the configuration of infrastructure and deployment of code in a similar manner to how they manage their software development process using a familiar tool, Git. Protecting secrets is not a small challenge in software development. Database passwords, API keys, TLS certificates, they all need to be carefully protected and changed regularly. Fortunately, cloud providers are designing services to make this process easier, as does HashiCorp Vault. Also, Kubernetes provides a native secret object that can be used to protect any sensitive information needed within the Kubernetes cluster. However, getting your secrets securely from backend secret management systems into your cluster to be stored as Kubernetes secrets has presented some security challenges, and teams have had to create their own solutions to fill the gap. Kubernetes External Secrets does a great job of securely solving this problem. So. Now, above all, our #1 rule for secret management with GitOps and Kubernetes is, of our don't bake in the 10 guides, is don't store raw Kubernetes secrets in Git. If you take nothing else away, that is the rule to remember. Thank you for listening and watching this talk.